Yeah, hello and welcome to our lecture series on climate protection. So, as I wrote you in the email, Albano Ilo apologize for today. She's ill, so we have to postpone her lecture, but I'm happy to welcome Lindsey Nicholson today. She was announced for the keynote lecture. So yeah, I'm very, very pleased that Lindsey was able to step in at such short notice today. Lindsey Nicholson is professor at the Institute of Atmospheric and Cryospheric Science Center for Climate. She is a glaciologist, geomorphologist, and climate scientist. Her research focus is on understanding the relationship between glaciers and climate in order to better understand how the climate system works and how glaciers and the related Earth system will change in future. She worked in Nepalese Himalaya, Norway, European Alps, Queen Elizabeth Islands, Arctic Canada, Svalbard, Alaska, the Chilean and Peruvian Andes and mountains of East Africa. She's interested in understanding more about environmental change and specifically how it will affect sustainability of ecology systems and populations. But additionally, to her work in academia, she likes to communicate her findings to students and wider public. She also bridges the gap between art and science, similar to Andre Sner Magnusson. We have seen the video last time in the last lecture. He's an artist, and Lindsey is not only a scientist but also an artist, and her work explores the boundaries of scientific and artistic inquiry or understanding and how they can generate meaning in society. This artwork shows one of her latest work in University of Applied Arts in Vienna. Also, today's event is science communication in a broader sense. We are looking forward to her presentation today. The title is a more than specific approach to motivating climate change mitigations. Welcome, Lindsey. Thank you very much for coming.
So I want to talk about motivating climate change mitigation. And I think this lecture series is a really interesting example of bringing together the multidisciplinary inputs that are needed to try and address the challenges of climate change and creating a livable future in which we can all thrive. So my abstract was a bit like this. And first I'm going to, I work as a climate scientist. So first I'm going to talk to you about some of the latest findings from the last IPCC report, which you may all be very aware of. So I will try and go reasonably quickly through these, but to highlight what's there to be won in mitigation, like why are we trying to mitigate climate change really? And then I will go on to discuss 4 of my kind of non-scientific research activities, and they're the ones listed here. And the point of doing that is to try and talk about the different ways that are maybe needed to motivate people to action and to uptake some of the many solutions that are around, and probably you hear more about in this lecture series and in the past year's lecture series that we have here. So this is just a brief summary of the kind of action and impact we have had, or human actions have had on Earth, comparing the world populations from 1960 to 2020, the fact that we've only in a few decades burnt about 40% of all the known oil reserves. We may find more. But this is a strong imbalance between the amount of time that it takes to form such fossil fuel reserves and the rate at which we're consuming them. 70% of the ice-free land surface has been altered by human actions, and 1 kilogram of concrete is poured per meter squared of the land surface. So the charts are showing time along the x-axis, in the upper part greenhouse gas concentrations, and at the bottom the global anthropogenic carbon dioxide, specifically emissions split into the fossil fuel use, cement construction and flaring of gas from oil extraction areas. And the greenish color is forestry and other land use changes resulting in anthropogenic carbon dioxide emissions. So the reason I show this is not to be depressing, but actually kind of in the other way, to say that not only can we really see the observable impact of human action on the climate, which I think everybody in this room is very well aware of, One of the big things that you hear quite a lot is that it's too difficult for us to change our existing ways, or it's too difficult it requires too much for us to change the climate system and our impact on it. But if you look at this, you can see that actually, I see it as the other way around. If we were powerful enough to do this in the first place, we're absolutely powerful enough to act against this now that we have the knowledge. So I see it not only as explanatory, but maybe also quite motivational. The other sort of relevant thing is that this is greenhouse gas concentrations. So in green, the carbon dioxide, in red, the methane from the oldest ice core that we have on Earth. So it's measuring the fluctuations of greenhouse gases over the past 800,000 years. And the modern day for 2023 are the numbers I've put up here at the top. Carbon dioxide in 2023 was 420 parts per million over the globe, and methane 1,933 parts per billion. And what you can see here is this is like more than doubled the maximum range over this whole time period in the past. And if we compare the carbon dioxide, it's also, this is 300 to 180 if the numbers are a little bit small at the back. So it's going well outside the envelope of fluctuations that span the time that humanity evolved. Like Homo sapiens started emerging about 300,000 years ago. So we evolved in this last part of this record. So we're really like in a different climate to the one that we evolved in. Most of the data that's known about how our climate system is changing, and indeed our impact on it, has been collected in these reports by the Intergovernmental Panel on Climate Change. And so it's really an international effort from scientists who do this in their spare time, not financially compensated beyond the compensation we have in our own jobs, to collate all the information and compile it into reports. And I think it should be a place for the primary source of information, not just for the physical science basis. And these are the examples I'm showing here because they are the parts that I work in, but there are also reports based on solutions, mitigation, adaptation. And so I think these are really powerful reports that summarize like the best state of our knowledge. And I'm going to show you some of the like observed conclusions from the latest report, which is the AR6 report. So what we can see here is the headline statement that human influence has warmed the climate at a rate that is unprecedented, at least in the last 2,000 years. And this is what we kind of see in these charts. This is time along the bottom. So this is the period 1850 to 2020, and we see the sharp uptick. And what we can see on the right is that we know the attribution of this uptick in global temperature can be attributed to human activities, because when we run climate models with all the actions of all the natural cycles and processes, but not human activities, we get this kind of blue line. And if we include the activities of human societies, burning fossil fuels and changing the land surface and all the things we saw in the first diagram, only then do we manage to get this brown envelope of likely change, and this black line is the observation. So this is the key way that we actually attribute that the observed changes belong to or are caused by our activities, and it's really unequivocal. In the observations available, we can see that climate change is affecting every inhabited region across the globe. Here's a very schematicized kind of map of the world. This is WCE, is West Central Europe, just to orientate yourself on the map, and these are the Americas. And what we can see in these diagrams is that these are the observed change in hot extremes, red being an increase and the gray colors being where there's not very good agreement or there's limited data available. And so what we can see is across the world, we're having an increase in hot extremes. The same kind of pattern predominates for observed change in heavy precipitation. And the dots in here show the confidence with which we know these changes are happening. So there's more confidence in the temperature of the precipitation, but the pattern is clear. If we want to look ahead and understand what is happening to our climate in the future, we need to produce model projections. For this, we use global scale climate models. which are mainly developed by each country's National Weather Service or Climate Research Service. But to know what might happen in the future, this diagram is from the Coupled Model Intercomparison Project, this CMIP shortening, and it kind of shows you all the data that goes into improving these models, or goes into feeding these models into the future. But the other key important thing we need to have that goes in there is the human behavior. So we need to know what our emissions are going to be. We're like a critical determinant of what might happen in the future climate, okay? So the projections going forward into the future depend on the societal choices. And I also wanted to say, if you want to interrupt me and have questions, I'm looking at you, so please just raise your hand. And if it's easier for you to ask your question in German, please ask in German. We'll manage, just so you know.
And I'll come with the mic because the people online can't hear you in the lecture hall. So just raise a hand, I'll give you the mic, and then we can ask you a question. Thank you very much.
Thank you. So the important thing we see when we're thinking about what are these potential futures based on our actions, we have these so-called shared socioeconomic pathways, SSPs, and they kind of describe different sets of political behavior. And they've got these kind of maybe quite storytelling names, the middle of the road, regional rivalry, but they actually represent like likely story tales of how politics and policy might evolve. And they are related to, within these kind of shared socioeconomic pathways, which describe our societal actions and what we do, the types of societies we live in, they're associated with certain amounts of warming at the end of the century, so 2100. And for example, when you see these charts, I'm looking at the temperature change related to different levels of future emissions and these societal scenarios. So what you see here is SSP1, and this number 1.9 refers to the fact that at the end of the century, there's going to be plus 1.9 watts per square meter on average, more energy being retained at the Earth's surface. So this is very specific at the end of the century, the amount of energetic forcing, and we can also think of that as a kind of, you can see a temperature equivalent, but it's the so-called radiative forcing. So on average on the spinning globe in space, there's a certain amount of watts per square meter of radiation retained at the Earth's surface. I mean, in these various scenarios, they change, but this is why we can have two potential pathways, even with the same societal plan, this SSP1, which is the pathway to sustainability. We could have a lower or a higher emissions rate within that, and they cause different degrees of global warming. The left bar is the total observed, and then we see an attribution of that to carbon dioxide, non-carbon dioxide greenhouse gases or aerosols or land use. But really you only have to look at the first bars to see that depending on each of these scenarios, going from the most sustainable to the most pessimistic scenario, with a total of like 8.5 plus 8.5 watts per square meter energy coming in over the whole globe at the end of the year would, at the end of the century, would give us a potentially warming over 4 degrees. Okay, so all I want to say is like the degree of greenhouse gas emissions is critical to the type of future that we're going to live in. And this is why mitigation is important. With every increment of global warming, the changes get larger. Here we're looking at the annual mean temperature. So this is 1.5 degrees global warming. The middle one is 2 degrees global warming. And here we are at 4 degrees global warming. So mainly you can see that the patterns, the spatial patterns remain similar, but the intensity grows. And these two at the top right are really just showing the observed change in the historical data and what the models simulate with the 1 degree warming, like up until our present level of warming, just to give an idea of the reliability of the model. There are some discrepancies, but we kind of want to say that these are quite convincing that the models perform well, and so we can consider this reliable. The same for precipitation, which I won't go into just to keep moving forward, and the same patterns for soil moisture. So these are all available in the these are all available in the from the IPCC. And the other interesting thing in the latest IPCC, there was a new development, because actually we've been having IPCC reports now for decades, and the messages, the exact wording of the messages changes, but the main message that we're having an impact, that we know it's us and it's going to have an impact on our lives in the future, hasn't changed much. But what this latest report gives us, which is quite interesting and relevant, especially if we think about the kind of weather cycles that parts of the globe experienced over the last year, is that extreme weather events are much more, well, are shown to be more likely. And here's an example of the type of figure they produce. This is a warm extreme, so a hot extreme over land. So the left panel is the historical data, meaning that for these 10-year events, once in every 10 years, you would have a heat wave like this. And this chart on the bottom is showing kind of the intensity of the heat wave, which isn't shown really as a graph here. But what we can see is in the global warming level of 4 degrees at the global scale, then actually what was a once in every 10-year event would become almost the norm, happening 9 out of 10 years. So this is a way of showing the shift in these extremes. And I think we all know from reading the newspaper that these extreme kind of weather systems have become increasingly present in our news, not just, well, because more people are being affected by them. Yeah. And the graph on the right is showing the same thing for a 50-year event. And we can also see on the bottom here the increasing intensity of the warming. So how hot each of the top part is how often a heat wave happens, and the bottom part is showing how hot is the heat wave going to be. This is the same chart for heavy precipitation over land and agricultural and ecological droughts. So we have extremes changing. If we think about the kind of area that I work in, I work as a glaciologist here at the University of Innsbruck and a climate scientist, but mainly on glaciers. What I'm showing you here is a comparison for different levels of global warming. So blue is 1.5 degrees warmer at the end of the century. The yellow is +2, the light red is +3, and the dark red is +4 degrees warming at the end of the century compared to pre-industrial levels, okay? And the dotted lines are showing the volume change of glaciers across the whole of the European Alps. And the solid lines are showing the volume change of the glaciers just in Austria in comparison to the whole of the European Alps. So what we can see, for example, in the case of glaciers, if we go to these like warmer scenarios, we are for sure going to lose all the glaciers in the Austrian Alps by the end of the century. If we stay at this 1.5 degrees warming, these are model projections, of course, the climate model and coupled to a glacier model. What we can see here is some percentage of the ice volume of 2022 could also be retained. And I use this just as an example to show there is still much to be won. We're used to hearing negative stories. The future is bad for the glaciers, but we could still retain some of it. And if we're careless and reckless, we will lose all the glaciers in the Austrian Alps, which is kind of interesting for a country that part of our identity here in Austria, I think, is tied up with being a mountain and a glacier area. There's a question, please, Rainer. We'll just wait for the microphone, if that's okay. And I'll have a drink.
Hello, everyone. I just heard a news from Switzerland. They already put like an ice melt, like cover on the mountains, so that maybe protect the mountains from melting.
That's right. And if you ever go skiing around here in Austria, you'll see it also used quite heavily. They put like white insulating blankets over glaciers in many ski resorts to protect the infrastructure and to protect the connections of pieced connections between different parts of it. There is an experiment in Switzerland to look at, would it be possible to geoengineer the saving of a glacier called the Morteratsch Glacier. And the project, if you want to look it up online, is called Mort Alive. And they try two things, covering the glacier, and they also try using artificial snow machines. So making fake snow, also a technology taken from the ski resorts, and try and do calculations for how much fake snow would we have to, or man-made snow would we have to spray over the glacier to try and save it. That study shows that at the scale of even a small glacier like the Morteratsch Glacier, it's not really feasible. And the amount of energy used to pump the water actually outweighs any sort of savings. We couldn't do this at scale. Yeah.
Dankeschön.
Thank you. And also the plastics of these blankets, it's PET and it's cracked by ultraviolet radiation. So it starts to be microplastics. So that's also not good for the environment. Okay.
Exactly. There are other negative consequences. So in short, the point is at a small scale it could work. With negative consequences at a meaningful scale for saving the glaciers, it's not possible. The other point I wanted to make is that this graph really is just showing that every ton of carbon dioxide we emit adds directly to global warming and in a more or less linear fashion. So we're used to people talking about the climate system as being very complicated. And it's actually, of course, it's true, knowing exactly what might happen in a specific region is related to all kinds of so-called teleconnections and adjustments and noise and standing patterns within the climate system. But the main message here on the y-axis is the global surface temperature and the increase since 1850 to 1900, so since this pre-industrial period, as a function of the cumulative carbon dioxide emissions in gigatons of carbon dioxide. What you see in the bottom part, this is the historical warming in black with the envelope of uncertainty, and in the colors are the projections. So I find this really useful when people kind of start considering and arguing other options or causes for the observed temperature changes, because it's linearly related to the amount of greenhouse gases, and we are the ones who are perturbing the greenhouse gases. So this is my go-to figure to be yes. So all of that to say that mitigating this climate change is really primarily going to be achieved by limiting or preventing greenhouse gas emissions, and by enhancing activities that remove these gases from the atmosphere. And there are many other actions to be taken, but this is kind of something I want to talk about here. This is a kind of infographic from the World Wildlife Fund, or Worldwide Fund for Nature, I think it's called now actually, comparing the different futures based around the results of an IPCC report, a special report which was comparing the difference between if we have 1.5 degrees warming or 2 degrees warming. Did you all hear about the Paris Climate Agreement at one of the conferences of the parties? I think it was the 26th or 25th actually. But when we talk about the Paris Agreement, it was trying to limit global warming, an international agreement to limit global warming to 2 degrees, to take actions to do that, and if at all possible, to fight for 1.5, strive for 1.5. And this was all of our governments signed up to this. And around the same time, the IPCC was requested to make a report actually identifying the differences, what's to be won. And so this kind of summarizes it. And I think it's large enough for you to read, but you can see really there are large differences in the impacts. Let's just look at an example here. Water availability, 350 million urban residents exposed to severe drought by the end of the century, versus if we have +2 degrees, 410 million. So in all of these cases of impacts, 46 million people affected by sea level rise, or 49 million people here. Ice-free summers in the Arctic once every 100 years, ice-free summers in the Arctic, sea ice-free summers in the Arctic every 10 years. So this is just summarizing that in this 0.5 of a degree, there's much to be won in the difference. The choices we face now are also summarized in this other infographic. We've got a so-called business as usual, which I'll kind of debunk a little bit later. Some mitigation, giving us to a pathway that was probably going to go across 2 degrees. This doing nothing at all is likely to have temperatures that really rise well above 2 degrees. Strong mitigation, we might hold the line at 2, and aggressive mitigation might really increase our chances of staying below 2 degrees. And one of the key questions, or one of the key things that I took out of this report, this special report on 1.5 degrees, is the question of, can we even really stay within 1.5 degrees? And I think the first thing, those of you who've been reading the newspapers or hearing the news just now, is that we're very, very close to this limit already. But if you remember how climate change, or how global temperature changes, if I just flip back here, we see there's quite a lot of wiggle and noise, yeah? So a couple of years reaching this threshold doesn't necessarily mean that it's all is lost and we've gone over it already. And in fact, for almost every scenario where we still are trying to stay within 1.5 degrees at the end of the century, so in 2100, we actually bob above it and come back down, yeah? So we're not to like lose all hope when we see reports that we've crossed this threshold, because all of these understandings and impact assessments are based on where we are at the end of the century. And just so you know that there's this bob over. What I'm showing here is some different pathways. These, you don't need to know like incredible amounts of detail about these, they're within the report. But basically it's a way to stay within 1.5 degrees. We need about net zero in greenhouse gas emissions around 2050. And there are various ways of doing that. Let's look at the one on the left, is to rapidly divest from fossil fuel and usage. And then the one on the right like allows us a much stronger and longer time to adjust. And so we continue to use a lot of fossil fuels. And you'll see like large differences in the areas of this yellow part. And this is the carbon capture and storage part, and the brown bit is like changing agricultural, forestry and other land use impacts. So here you can see the more we continue, or the longer we delay divesting from burning fossil fuels, the more we have to rely upon these other technologies to achieve net zero. Like all of these pathways are achieving net zero around 2050. It's just one of them is doing it by pulling on a lever that we really know works fast, and others are requiring upscaling of carbon capture and storage technology. And the technology like exists and is developing all the time, but at the moment is still not available to scale to remove this 100 to 1,000 gigatons of carbon dioxide over the towards the end of the century. So this would be, I mean, it depends how you interpret this. Like I choose to interpret it as like we should divest as rapidly as possible, because that's a easy choice. But of course, like it's not really an easy choice to disentangle our whole societal way of living from fossil fuels. And somebody who takes a more like a technological innovation view might say, okay, what we have to do is allow ourselves this period where we're still consuming more fossil fuels and invest very heavily in improving this carbon capture and storage. And I think I just put it here to say that there are different ways, because I think in this lecture series, you hear about many different pathways to participate and contribute to the solutions, and you can choose the ones that appeal to you most. There's no harm in us divesting hard and investing in technologies that would allow us to expand carbon capture and storage. There's only a win, so you can choose your own preferred pathway in a way. The other thing I would say that restates that sort of actions are helping is this diagram from Nature, which showed that actually the International Energy Association, even they and most of the climate scientists now also kind of agree that because we are implementing climate strategies, this worst case scenario, no policy trajectory, and this is again the global fossil fuel emissions rather than the temperature, this is highly unlikely, and it's often called in different representations business as usual, but actually we're not doing business as usual. So these very worst case doomsday scenarios about the rate of emissions we produce and the associated temperature change maybe they are pessimistic, right? So a more realistic one is looking at if we keep implementing further innovations and policy strategies, something around this 3-degree range, which still is problematic. So we should still be trying to go for a smaller and smaller pathway here. And climate policy has really been, so far, has really been inadequate to deal with this. On the graph here on the left, we're kind of above 1 degree of pre-industrial warming already. The Paris Agreement goals were to hold global warming to well below 2 degrees. The current existing pledges and targets promise like a level of about 2.4 degrees warming by the end of the century, and the actual implemented policies get us to about 3 degrees of warming. So that's kind of in line with this graph range here of what might be expected. We can keep hoping for more, but I think we have 2 big levers to take action. One is to lean on and demand better climate policies and keep doing that, which always has like a key tension to limit our impact on the climate while delivering on the sustainable development goals for all. And I think these are, they're important to work together, but they're actually like quite difficult to combine in some cases. And then for me, the other question is a lot what's possible with personal action versus what has to happen at a much larger and higher scale. So I wanted to talk now about kind of communication and motivation for action, because I hope I've shown you that there's plenty of evidence that we have agency in our climate system, that there's much to be won by minimizing the temperature, global temperature rise. To minimize that would require like a direct linear relationship with the greenhouse gas emissions. And what I want to say is, even with all this knowledge and information is out there, and I actually really like the Our World in Data webpage about climate change and the environment. It has quite a lot of nice summary graphs that can answer open questions about what is the most energy consumptive sector in here or there or whatever. And finally, about information, this is a graph from the 2021 World Economic Forum Global Risks Outlook report. The data is more or less the same in the 2023 report, but this graph, I liked it better than the way it's visualized in this year's report. What I want to show you is this is like an impact and likelihood risk outlook. And most of the ones up here, so the highest impact and the highest likelihood, climate action failure, biodiversity loss, infectious diseases, we all know what was happening around 2021, human environmental damage, extreme weather. So when environmental campaigners kind of consider the World Economic Forum, I don't know, the enemy, that's maybe fair or simplistic or whatever, but the point is that there's no disagreement of the information, right? The World Economic Forum also thinks climate action failure is the biggest and most likely risk, or the highest impact and most likely risk. And it's true that that's the case for when you look at their risk reports over 5 years, decadal, and into the future, which I always think is interesting, right? Because not only do we have these, the World Economic Forum says it's important, our governments all sign up to the Intergovernmental Panel on Climate Change, they agree with these headline statements that I showed you at the beginning slides. They've signed off on it. And yet, where's the conversion to real action? So a little bit the statement, authoritative institutions of experts with government support and funding do the climate research, the anthropogenic influences are unequivocal, future conditions depend on our choices now. But we do have tools, we do have capability, and the knowledge and solutions are actually reasonably well known. We have many we could deploy. And again, I think you learn about them in these lecture series, and also in the ones from like past years. You can see many examples of methods that could be deployed, but we're not really like implementing at the scale. So for the rest of my talk, I want to consider part of one of the problems of why this doesn't convert into action. And I would put it this way, like the idea that the information deficit model is not sufficient. This is very a geeky way of putting. It used to be that people in climate change communication always said, we just need to tell people what's happening. And then, you know, obviously people will do something. Nobody wants to, you know, shit in their own bed. Yet this doesn't really solve the, it doesn't solve the gap between action and the information, right? And so what I was showing you in those last slides is the information is really there, and yet it's not enough to motivate, maybe not us personally. I know, honestly, I don't do everything I could in my life to be more sustainable or reduce my carbon footprint. Some people do, and I admire them. I don't manage all of that, and our governments certainly don't, right? So there's the quote up here, and a lot of communication about climate change gets it right about the risk and possible negative scenarios, but wrong about how to accomplish the critical goal of not just raising public concern, but moving people to action. And the idea behind this is that giving people more information actually can be a bit incapacitating. We can be like, okay, now I know all this stuff, but what do I do about it? And the other thing is people's behavior is driven by different sets of motivations. We're driven by emotions, we're driven by community, we're driven by other things that are enmeshed in our societies that don't necessarily aren't fulfilled by just more information, another report, not fulfilled by the kinds of slides I just showed you, maybe. And so this is some information from a website from an organization called the Climate Exchange, talking about how to communicate the climate crisis. And they had like 4 big problems. One is jargon, one is temporal and spatial dissonance rather, sorry, that like when we see pictures of polar bears in the Arctic, it's difficult for most of us to care because most of us have never seen a polar bear in the Arctic, and so on. That we have this information isn't enough, and that stories are looking like quite pessimistic. So ideas that might be more empowering and motivating to change might be to provide a vision of the future that is appealing, right? Why wouldn't we put forward a vision of the future where we're heroes, we've done it, we've made our lives better, and we've made smart choices, and we can collectively be proud of ourselves because we've actually understood a problem and gone forward and tackled it. And of course, many people and organizations are doing this and fighting this fight, and thank goodness they're here, yeah? The other thing is to connect the dots about things that people already care about, and not really to shy away from the uncertainty, like the fact that we might try something really hard and have it not work because there's some feedback, some knock-on effect that we haven't encountered. We have to be brave about that and still try, and also to speak through the data using storytelling and more human appealing ways. Another interesting theory that I try and work with quite a lot is that looking for points of so-called deep leverage to change a system. So it's a kind of schematic, but basically we could spend a long time discussing it. It's from a paper that's linked here, but you can say that basically like small tweaks to how a system operates is not so important as changing your mindset. A trivial example, for example, would be, so we go to our Mensa here, and everybody could buy a reusable cup if you don't have one. So it's there, the system has been changed. It's easy for you to do, right? But you're only going to do it if you've got to the mindset state point where you actually feel shameful, like your palms sweat, you feel hot shame if you take a paper cup, right? This is what changes your behavior. It's how you feel about it inside. You caring about it is what will make you use a reusable cup, not just the reusable cup has been made available. Does that make sense? So this is this would be the example of a deeper leverage point, is for you to change your mind and paradigm and belief about the world or about yourself in the world, rather than just making structures. Structures are important. This is still working on the lever. I'm not saying it's not important. All of these things, changing processes, redesign, making things easier for us to do the right choices. These are all important parts of the story. But right out here on the end of this lever is thought to be our mindsets and what we believe we can do. So in my work, I try to find different ways to engage, and we can talk about them afterwards if you think they're meaningful or not and what your own ideas are. But I'm going to talk about these four. So within my university activities, I try and actively empower my students, not just give them here's some facts, but remind them that what they could do with these information and how I can use my own position as a university professor to advocate as an expert. So say yes to opportunities where I get to speak in public or contribute to a lecture series like this or whatever. Take the extra work because there's a privileged platform in this and it's nice to try and use it. The other one is, the next one is a program called Girls on Ice, through which kind of two projects with appalling names, maybe Girls on Ice and Protect Our Winters. But the first one is about bringing diversity to leadership around environmental matters. And the second one, hands up who's heard of Protect Our Winters, the organization. For those who don't know, well, I'll tell you what it is. It's, I think, connecting to engage for action through making a connection through a passion for outdoor sport. And then through artistic activities. And I think it's a growing field for scientists to try and work in collaboration with artists. And I mean, if we think way back, I mean, you don't have to be a huge fan of the Renaissance times to know that back then, science and art was not really separated. Knowledge was together, and it's only later in time that we've tried to like put these things in separate boxes. And they are different activities, but there's no need for them not to actually work together and overlap and cross-fertilize their fields. Okay, so I said I try and use the platform that I personally have the privilege to be a professor at the university. It gives me opportunities. As a student at the university, it also gives you opportunities probably, and things you can leverage and societies you can start and movements you can begin. And I try and use it where it's possible for public engagement, even if sometimes that leaves me very exposed. It's very nerve-wracking. It's not always a comfortable experience, but I will try and do it, and I will try and do it the best I can. I also think through organizations like Scientists for Future, as an academic, I can be, maybe I don't want to be an activist myself, maybe I do, I don't know. But at least I can be an ally to activists. So I haven't stuck myself to the road, but I've stood by people who have stuck their hands to the road. And I think this is important to provide support from all the ways you can. I also contribute to national initiatives, such as there's an ongoing Austrian assessment report, it's called, which is really a poor title because what it is a climate assessment report. It's assessment report doesn't really tell us about this, but it's trying to understand both what's happening to the climate in Austria, what will happen to the future, and what specific things to Austrian life, economic, social, and geographical setting, what are our strongest, like what can we most effectively use to contribute to being part of the solution and to making a better life for ourselves. And so this is again like a volunteer report that scientists go and participate in. And I mean, we can also, as academics, choose to do research on solutions. Now, my actual research, I put a question mark here for me personally, because my research is normally this blue sky research. It's understanding first principles and processes and not very applied. But of course, as you'll know from across the University of Innsbruck, I could do more applied projects, and there are many departments which are doing very applied research to generate solutions and to experiment with solutions and find out which are the most likely and beneficial pathways to follow. The other thing I do with my students is I try and like educate in a way that is hopefully a little bit interesting and inspiring, but I also try and give meaningful assignments. This is just a screen grab from the, I should have put the link down here, sorry, to the Instagram of The University of Innsbruck Climate, it's UIBK_climate, if you like following Instagram, and it promotes the research of the climate research that's being done across the university. And here are like 3 examples where in my classes I ask my students to produce infographics that are then posted on social media. So their assignments can be useful. If they want to go to a campaign, or I don't know, they produce a really nice infographic that can be used by any organizations they're in, and it's seen by the public. So instead of it being write me an essay and it sits in my drawer over here, I want people to feel that the work they're doing, the research they're investing in, can have an impact. I don't actually know what the followers are, or if this would be reaching like really an impactful audience, but it's one incremental step towards people feeling that their work counts. I talk quite a lot in my classes about ways to communicate about the climate crisis. Not always me actually, because my German's not excellent, but my group and our students, we do quite a lot of outreach, from the Lange Nacht der Forschung, when the public can come to the university, to visiting schools, to doing all kinds of trips and participation. And this is a nice way also to exchange with what people's real questions are, feel what people understand, hear what they're really worried about, because sometimes it's surprising, or people have different interests. And it's only by doing this connection out with our bubble that we start to understand what are people's concerns, and how I could have a conversation with other people about the topics of my concern, because it's not just my perspective isn't the only one. It's not the only important one. And a lot of my students, we've done training to do this climate education. So this is an information deficit type of course. It's a way to train people to explain the climate crisis. It's actually a kind of game that's done in a workshop. But there are many people who are trained to do it, and I train to do it through Protect Our Winters, which I'll talk about later. And I've encouraged many of my students to go and do it. And it gives you then the opportunity, if a company wants to hire somebody to bring them in and do this workshop in climate change, then you can do it. You have the answers, and you can go do that. And I also try and encourage my students to, I put it just here like leadership, but be aware that you have a kind of privileged position, you have the knowledge, and instead of thinking, oh, I wish it could be like this, have a go, make it like that. You might fail, it's the worst thing that could happen, and that's not that bad, you've tried. So I try and encourage people to get out and do something. So, and by the way, like, I'm by no means obviously the only person at the University of Innsbruck who tries to pursue these motivational tactics in their teaching. We have whole days where climate is weeks where climate is brought in through the actions of Fridays for Future, and we also have many initiatives and different like klima lectures at the university scale, and climate communication lectures, and so on. So this isn't like saying, look at me. I'm just trying to describe to you some of the things I do, and across the university, people are doing this as well. And now our rectorate is a little bit more active, I think, in general too. So Girls on Ice, let me tell you what it is. It sounds, it's got a kind of maybe weird name. What we do is, it's a group of all-female identifying volunteers who offer a cost-free week-long expedition to a glacier for young Flinter people. So young female identifying or genderqueer people, to allow people who maybe haven't had the possibility or experience to go into a mountain environment to come with us with no limitations. Addressing diversity in earth sciences is a challenge just now. Like, not everybody has the access to the money, or is culturally used to going into the mountains. When we look around, like, most of the wealthy Tyrolean youth all go up and down the mountains regularly. It's not everybody though, and there can be many reasons why that's not an option, and some people just don't want to, which is also fine. But for those who might want to and have a are blocked by various like access or dimensions of access. This is a program where we try and like break that down, because in every field, science has shown that the more diverse the group discussing, the more likely you are to find innovative solutions. So we try and make this opportunity, and we try and make it open for people who, it's a very, in response to our applications, it's a very qualitative way of deciding who gets to come. It's just who do we think might benefit the most. And it's done by a group of volunteers, and we go up to the glacier and we have an artist with us, we have a mountain guide with us, and we have a scientist with us. And we combine all these things. The outdoor adventure coupled to the scientific knowledge, how do they cross over? You need to understand the weather to plan your trip. When you're looking deeply in the environment, you might not just be making quantified scientific measurements, but you might want to just observe the landscape in the same deep way that you do as an artist. All these boundaries blend, and we try and teach them together as a package. We only take 9 people a year, so the impact in some way is small. These are screen grabs from the Girls on Ice Instagram, and a quote from one of our participants. Okay, so I think at least one-to-one we have an impact, and also this I love talking about it tells us that like it's nice. We've trained or promoted our participants into wanting to speak about their experiences and share them. Past participants here have gone on to win like youth journalist prizes, writing about the program and writing about each other and their different experiences, perhaps immigration experiences and cultural experiences. And they've also come to present the program at the European Space Agency conference 2 years ago in Bonn on a huge stage in front of loads of like satellite scientists. So we try and keep giving them these opportunities to develop leadership and say, okay, I can do more than I thought I could. That's the main thing I would want participants of this program to come out with at the end, is saying, I can do more than I thought I could. I'm also associated with Protect Our Winters. I like this quote. So if German's not your thing, it's progress instead of perfection is the thing. And I find this a very useful credo, actually, because do you remember when Greta Thunberg like took a boat all the way across the Atlantic to go to a climate conference, and nobody said, well done her for trying to attend, participate, but do it in an as ethical a way as possible. Everybody was just like, well, she didn't have to do that at all. She didn't have to travel. There's no value in it. So the narrative around actions around climate has a deep tendency to be a bit like nitpicky and pick out the negatives. And I think that's truly counterproductive. Like, if you choose to do something that I think is less important than what I'm doing, who cares? You're doing something, I'm doing something. It's better than us not. And it's much better than me or you saying to each other, well, I don't think what you're doing is useful. And then you stop doing it, or I stop doing it. Not great outcomes. So I think this is a really like good tagline. And the other super important thing that I think Protect Our Winters does is it uses, it creates a shared passion. So what it is an organization that started around winter sports athletes, skiers, snowboarders, wanting to, this is why it's called Protect Our Winters. It's not really an organization about protecting our winters, but basically it's connecting climate and environmental activism to a shared passion for snow sports. And it's even expanded now to beyond snow sports and all kinds of sports. And so they have these particular alliances where they have, like people's athlete heroes who are then the advocates for environmental change. Maybe imperfect environmental change, but trying to do actions to make a difference, speaking about it, taking action. And Protect Our Winters was part of like an initiative like where the Protect Our Winters athletes who competed on the last like World Free Ride Tour, like all the free ride skiers and snowboarders, this was, they traveled by train all across Europe, whereas previously they probably drove or took the plane. And I mean, skiing or snowboarding might not be your thing, but we can all understand that we all have heroes, I think, and when our heroes are the ones who are advocating for change, this connects to us more than when people we don't identify with at all or don't think are our heroes advocate for change. And so this is a thing I think Protect Our Winters does that's quite powerful. It's also come under criticism for sort of how can you be from a generally unsustainable activity, say that you're like climate lobbyists when you're doing something that somehow is intrinsically maybe unsustainable and unnecessary. But this is also part of this imperfection thing. We're people and we do things imperfectly. And so better if we do what we can and connect to our passions to deliver change. So I think that's an interesting thing. And they have like these alliances with athletes and scientists, and I'm one of the people in the Science Alliance, and there are many, many more. Some of the things that Protect Our Winters do is also outreach and education, and they have their athletes stand and do things like lobby the ski industry and, as I said, travel by train. And also they do quite a lot of, in the US, for example, they do quite a lot of active research to decide what would be the most environmentally friendly way you could vote in your region, and then use their athletes to convey this very political information to people who might, I don't know, they might not be reading the politics parts of the newspaper. So I think they do some quite clever things, even if it might be, like all organizations, a bit imperfect. Wanted to talk a bit about art interventions. I don't think you need to read the texts about these. Many of you might have heard of this or heard of or seen this installation called Ice Watch by the Icelandic artist Ólafur Eliasson. He took chunks of ice from Greenland, actually, and put them in different places. And then people watched them melt over time, and people interacted with them. And I think many people found this quite touching. Again, there are problems. He took the ice from Greenland. It was an iceberg. It was already broken off and floating in the ocean, but it was still dragged by a ship. That's not the most efficient way. But then again, as my introduction said, like in my research, I've also been many places to do my research about climate change. Things are not always consistent and not always perfect. This was really well received by people. They felt moved and touched by it, knowing that this ice was really ancient and they were watching it melt away in front of their eyes in their city, and they couldn't do anything about it. But also this idea of getting close to the ice. Like, we are quite lucky here, we're kind of close to ice. If we want to go and visit a glacier, we can, but most people don't. So how do we tell them to care about the ice? If you've never been close to a lump of ice like this, you know, it smells different, it feels different, it's smooth. Obviously it's cold, but it's smooth. It's got different, beautiful sculptural forms, and you can create a kind of connection to it through works like this. Closer to home, and only in 2021, this is like the release of a glacier bred in captivity, I think you'd maybe translate it as. It's a work by Christian Ruszczyka, and he's from the University of Applied Art in Vienna, but he did this action in collaboration with scientists from the University of Innsbruck as well. And what he'd done is he used actually a very environmentally friendly, like ancient freezer system to create ice in Niederösterreich, and then transported it, and all these people carried it in specially made boxes up to the Geisbergferne in the Ötztal, and just like put it there. So this kind of like art intervention, it involved quite a lot of people, and I don't know, like, it doesn't work. Art never works for everybody at the same time, but some people found this quite moving, and some people maybe found it stupid, but plenty of people wanted to talk about it, and this is maybe the interesting thing. One of my favorite artists is Katie Patterson. She's a Scottish artist. I don't just like her because I'm Scottish, but she does, I think, very beautiful and meaningful conceptual art. And this was one of her really early pieces from far back in 2007, Vatnajökull, The Sound of. And so what she did is she put a geophone underwater in front of the lake that's in front of the glacier. And you could call it at any time and just sit on the end of the phone and hear like icebergs breaking off the glacier into the lake. I mean, you might pick up the phone and you hear nothing, But again, like this is one of these artworks that tries to bridge this connection or the spatial disconnect with impacts in our actions, maybe. More well known, I think many people might know, give me a wave if you heard of the first glacier funeral that happened in Iceland, or if you've heard of the glacier funerals that happened in Switzerland or Austria. Yeah, so the first one, not so many, I thought maybe more. So the first one, yeah, so last year and a couple of years earlier, there were glacier funerals held in Austria and Switzerland, but the first one was in 2019 in Iceland. And the plaque reads in English, "In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it." Great words. I think it's a really nice memorial. Again, not everybody's got to be touched by it, but for me, this really touches me. And again, people can have mixed feelings about it, but these kind of interventions open discussion and maybe allow people to feel connected to things that they couldn't. I've spent the last 5 years also studying art at the University of Applied Art. 5 years because it's really hard to do an art degree alongside a full-time job at a university, by the way. But I've produced works that are like land art, video art, online experiments, and sculptural works that have been showed in Vienna and Serbia and Croatia. I don't consider myself a successful artist or a meaningful artist like the examples I was showing you before, but I've found a lot of value from having conversations around my art and by engaging and collaborating with artists. One of my ongoing projects just now is one called Ice Memory, in which I collaborate with a Swedish archaeologist and composer and a Dutch curator and videographer. And we're taking images of ice cores. This is the layers in an ice core. So an ice core is about 10 centimeters across and a long tube, and from Greenland, it'll be 3 kilometers long because the ice sheet is that thick. And we can look at these layers and we can feed them through a digital synthesizer, basically, to produce notes that relate to this banding. And then Hans, the composer, is working at both digital compositions and classical string compositions that are based around the sounds that emanate from this, while Elina and I are working on structural and videographical materials that would go alongside this. And it involves thinking about the problems and our connection to things and our ecological grief in different ways. And we hope that some of these kind of works would engage action or allow people at least to find a way in to tackling problems. Just last month, in fact, we did our symposium and a show in Vienna. A group of students from the University of Applied Art and myself, we spent a week on a glacier in Südtirol, and we had this presentation that was called "This is not a glacier: thickening description for thinning ice." And it was related to the ways that glaciers have been seen and narratives have changed around them. I showed you this graph of like glaciers melting away and said dramatically the glaciers will be gone by the end of the century, and like they will. But the point is that like it's not so long ago, like in the mid 1800s, that people here in Tyrol were scared of glacier advance. Glaciers were advancing and coming onto their fields. So between then and now, glaciers have gone through a whole narrative of representations of being threatening, being wilderness, being there to be conquered by mountaineers, being resources, and now being an endangered species. And I think art and discussions around art and science and the way that we're viewing the objects of our scientific research are quite important ways to like relate to these things. So I'm going to stop talking now and just close with the fact that scientific knowledge about the situation and what we need to do to mitigate or to find ourselves solutions for a better world is power. It's important. I'm not saying the information isn't important. We need this as a starting point for sure. But we also need to be able to platform and leverage that power in ways that actually create action and change. And I think this needs to explore all the different ways we can leverage that information and power and use it, both personally and structurally and organizationally. And we need communities. We need to find communities to support us doing that. And I would argue there's lots of ways to be part of the solutions, and solutions, technical and structural, are out there. And I encourage you to find your own way that appeals to you and do that. And maybe we can discuss some of your own solutions now, or I'll take criticisms or feedback on my thoughts about how I can have an impact. And let's see. Thanks for your attention.
Thank you very much, Lindsey Nicholson. That's really great. So yeah, we can start the discussion now. So again, if you want to say something, just raise the hand. I'll give the mic. And for those on the online participants, as the audio doesn't work, just type into the chat if you want to ask something. Then I can read the question and I'll answer. So then it works also with the online participants. Yeah. First of all, welcome to you all, and you all will actively participate in solutions as you do the performance task. You write some research questions on solutions from your field of research, and maybe we will feed all this information. It's many years now in a kind of database, and your colleagues can learn from it, and maybe grab the ideas, and maybe someday the answers will be the questions will be answered. So just for motivating you. Thank you. So are there some rising hands or?
Yeah, I guess first, any questions on the content of what I presented? I mean, maybe the second half is a bit more speculative. It's my opinion. Obviously, you can question me all you like on that, but also on the first part in the technical information. If not, then I'm going to ask you guys questions. So how many of you have actively been involved in like a climate protest march, Fridays for Future, or any of these things? Yeah. What would you mind sharing what motivates you to do it? Oh, sorry, yeah, now Rainer has to run with the mic.
I mean, just climate change is not anything specific, I'd say.
Yeah. Anybody else want to say why they go? Please. Thank you, Rainer. He's running around the room now.
Yeah, when many people are on the streets, they send a message to the politicians and to the whole world. And therefore, I'm going to those demonstrations to be one of them.
Yeah, thanks. I agree. For me, that's a big reason why I go as well. You know, like sometimes I can't even go for all of it. I have something else to go to, but I show up because everybody on the street makes it bigger. If everybody who said, oh, I could only go for half an hour, so I'm not going to go at all, like went, it would make for a bigger protest. May I ask, for those of you who haven't gone, would one of you or a couple of you like to share why not? Have you heard of them but not gone, or not really heard of them, or is it not your jam to march in the street? Like, I'm a terrible marcher. I don't like shouting. You know, people shout and do all the slogans around me, and I just walk along silently, I have to say. Love it if you'd like to share. There's no like shame or blame. It's definitely not the only way to have an impact. Thank you.
Yeah, I mean, I feel like for me, it's not really my jam, and I probably wouldn't feel comfortable being in a crazy crowd. But I mean, I like to take some actions that I feel like I can individually. I've been vegan a couple of years ago. I try not to use any plastic. So, I mean, it's like only small steps, but I feel like they can have an impact as well. It's like I just feel more comfortable doing it that way.
Yeah, and it's totally valid. Thank you for sharing. And I also think these small impacts these small changes, personal changes do have an impact. I mentioned earlier my example of like, you have to, like if you don't take a paper cup, I was shamed into never taking a paper cup by my office mate, Christine. She's not here anymore. I mean, she's not dead, sorry, but she's moved to another place. But yeah, she was so consistent about it. And I would occasionally just be like, oh, I forgot my cup. I'm just going to take this one. And she was always a little bit like, but why would you do that? Why would you not just come up here, get the mug and go down again? And I'm like, well, because I was passing it. It was easier. And I'm right and she's right. Why would I not just go upstairs and downstairs? Although you could start to get all complicated and be like, does it matter if I take the stairs or the elevator then? Like, wow, everything very quickly gets out of control. But the point I wanted to make about this example is her talking about it and saying, I wouldn't do that. And here's why I wouldn't do that, because it's so unnecessary, right? And I don't want to be like slamming people who take paper cups. It's just an example, right? I own a car, like nobody's an angel. I think that talking about what you've chosen to do and why it matters to you can have a much deeper impact about affecting the community around you and the choices they make than you think. And so this is an important thing, I think, to do the things you can and talk about it.
Yeah, and thank you. I liked what you said. You do want to express it in a different way. And there are so many ways. So Lindsey showed how what action is done here in University of Innsbruck. This is a Aurora lecture. So there are also universities from other countries. In this task, please also write me some of the actions of your home university, what actions is done there. So we can interchange. This was a really big presentation on possibilities also in kind of artwork or action or whatever. And I'm sure the other universities have similar things, so we can interchange the solutions. Thank you.
Yeah, and I think like your comment about joining a community helps, and maybe your community is a different community, you know, like a different way of standing up and being counted. I had something else to ask. How many of you, like a hands up, how many of you do you think in your daily life do think like, should I do this or that? Which is best for the environment? Is this something, I want to know if this is something that's running in your mind, because for me it is. Yeah. This is a hands up survey. Good. So most of us, we're thinking it, right? And I think this is also really valuable to see. I really care much less about what you choose to do than that you're thinking and choosing to do things and how to make the steps that you can. This isn't like any official policy from anybody, but I'm a huge fan of doing like the low hanging fruits. Do what comes easy to you instead of going and doing something that comes hard to you. Yeah, I also know people, for example, who don't want to participate in climate marches because they don't think that that's where the impact happens. They think it's deflecting from true action, which might be like spending that time remodifying your home, or I don't know, doing all kinds of different things. So there's space for all of these views. I've put, online there's a question: are there any climate protests coming up soon? Ooh, I have to check the internet. Anybody know? Anybody know? Yeah.
Tomorrow, 2 p.m. There's a student march, he said. Okay.
Marktplatz.
Marktplatz. Mm-hmm.
Thank you.
Mm-hmm. Okay.
Yeah.
Thank you.
Yeah. Oh yeah.
Okay. Mm-hmm.
Yeah, great.
4 o'clock p.m. Tomorrow, Treffpunkt Marktplatz. The marketplace, yeah. Yeah, you talked about the low-hanging fruits, and you showed the graph. So of the forecasting in the future. So what is climate neutrality? So we come down with the CO2 emissions, and then we have some changes in land use, hopefully in the positive way. And we have in far future some carbon capture storage. So, but the most percentage was the reduction of climate gases, or CO2 and methane.
Emissions, yeah. So in those scenarios that were presented in that particular IPCC report, the pathways or the storylines that were put forward for comparison were really just looking at the total greenhouse gas emissions, and making the point that because of that linear connection with the cumulative greenhouse gases, and I should do it this way for you guys, and the temperature. Remember the linear plot I showed you, the wiggles of the background, and then the projections in the future. Because it's linear, the main thing we have to do to change the temperature future of the Earth is to change the greenhouse gas composition. And you can do that by, you can do it by reducing the emissions, or you can do it by drawing down the emissions out of the atmosphere. And I think what I took from that report is that the first one is easier because we know how to do it. But of course, it's societally hard. I'm not saying it's easy. We're deeply invested and tied to the goods and services supplies that are very much underpinned by burning fossil fuels as an energy source. I think still now, like for all the global energy, it's less than 3% is renewable. We're still so heavily reliant on, I mean, in certain sectors, it's shifting more, the percentages, but that's still, we're doing great. There's solar panels and there's wind turbines, but overall, it's still less than 3%.
Yeah, but the other big power is the efficiency. So, and efficiency is available and it's low cost. It's even profitable. So if you save energy, you reduce the consumption of energy, you save money. So if you want to invest in carbon capture technology, that's high cost. It's not available in a big quantity at the moment. It's difficult technology for the future, but it's high cost. If you invest in 1 ton CO2 for carbon capture, you have to pay money. If you save energy, you get money. So you don't have to pay for the energy. It's a kind of low-hanging fruit.
Yeah, totally, actually. And also, like, so there's like increasing the efficiency of what we do using like waste energy, like heat energy, and yeah, being clever about what we're doing, not being wasteful, and improving. Yeah, I mean, your area of expertise, building efficiency, is a huge part of it.
Okay.
Wait 1 sec. Rainer's running with the microphone, so there's for people online, there's a pause.
I'm just curious about the glacier thing, because you mentioned about the ice blanket on the mountains in Switzerland. Whether you take actions or not, I think the ice is melting anyway, and it will be melting down at the end of the century. But if we do not take actions, what does this mean?
Yeah.
Like, what the difference between we might take actions or we keep silence?
It's a really good question, and it's quite trying to think how to answer it clearly, because you know how sometimes you're asked a question in your own expertise, and then you can go to like all kinds of depths of complexity. So for the Alps, you're dead right. So more or less, regardless of what we do now, by the end of the century, the glaciers will be gone or more or less gone. So let's call it effectively gone. And that's because glaciers take maybe hundreds of years to respond fully. So they don't care so much what we do in the future, because they're still responding to our actions of the past. We've already made the Austrian Alps not inhabitable for glaciers, basically. And when I say we, it's not just us in the room, obviously. But there's much to be won in when we think of the glaciers of the world, because by changing the future projections, we might still lose the glaciers in Austria, but the Swiss and French glaciers might survive. They're bigger and they're higher up, some of them. And so we might still have some glaciers in the European Alps that could be used as they operate like natural dams in drought years and can release water when there's none coming from the atmosphere and the groundwater is being stressed. So glaciers can be a useful supply, a useful buffer against hard droughts. And then when we look even further afield globally, the glaciers that will affect, maybe not us right here in Innsbruck, but like the huge Alaskan glaciers and all the glaciers round the fringe of Greenland, or the Greenland ice sheet itself, for example. These are the big sources of a third of the ongoing rate of sea level rise. So what we do, what temperature trajectory, what greenhouse emissions trajectory we choose has a huge impact on the impacts of glaciers on the world. Because, yeah, if we have 0.5 meter of sea level rise by the end of the century versus 1 meter, it's a big difference to the number of people who are affected by that, and ecosystems and opportunities as well. So thanks for bringing it up, because it's true. I was, 3 weeks ago, I was part of a panel discussion in the Patagonia store, which is organized by a collection of organizations trying to protect the alpine areas. And the talk was actually titled Gletscherschutz jetzt, so protect glaciers now. And I mean, as the glacier scientist, I'm pretty sure I was invited there to say, yes, we should protect the glaciers. But unfortunately, I also said, maybe this is the wrong slogan, because we're predestined to fail at this one, even if we take really strong climate action. And maybe that's going to be very unmotivating if we do all the things and are really, really good and the glaciers go anyway. Are we making false promises with this tagline? And so that was quite a difficult thing for me to have to say, because I support the protection of high mountain areas. But again, I'm involved in all these projects with terrible titles, like Protect Our Winters and Girls on Ice and Gletscherschutz jetzt. But the principles behind all of these, I absolutely stand behind. But it was an interesting, I was a bit conflicted about what I should say. And it was exactly because of your question. Yep, so thank you.
I think for our agriculture, it's not so much important, but in the Nepalese agriculture, it's rather important, because, as you said, it's a buffer, and it can also be a catastrophic impact if there are some lakes, then melting ponds, and if the dams break, it can have some water damage. That's really dangerous also, yeah.
Yeah, and that's a good point, because here in North Tyrol, the glaciers don't really support our water supply that well. But in the Pinchgau, on the south side of the divide, they're quite important. But if you've ever driven through the Pinchgau area, just across the border in Italy, where all the fruits are grown, here glacier runoff does do some work to supporting like irrigation in drought years. So it's thank you for the clarification. So it's very regional, like where it matters and where it doesn't.
Yeah. Any questions in the, no, not yet, not. Yeah, there's some.
Thank you for the opportunity. I have been in India for years, and they were protesting about not to use the plastic. And plastic is banned in India, and there is penalty to use plastic. So I'm curious about the warm weather. I mean, the countries that they experience the warmest weather. How would be the climate change after years or to the end of the centuries? How the climate affect their the human beings' life in warmest countries like India or other countries, and how we convey the messages of climate protection in countries that they don't, as the informations are available, but they are illiterate, and there must be something to give them the ideas of climate protection.
Thank you. Good question. So I think I could flip back through like a load of slides to look, but one of the things that's often said is that the countries who are most responsible for causing climate changes and not the ones who are most vulnerable to it. The ones who are most vulnerable probably haven't been the source of the major greenhouse gas emissions. And now, of course, like China and India are producing quite a lot of emissions just now, and the argument would be that somehow they're allowed because we did to get to where we are. And this is why I think policy is always in tension between this like climate protection policy and the sustainable development goals. Both very admirable, but maybe quite tricky to actually achieve together. I think, I don't really know about the climate awareness literacy in India, so I don't want to speak completely out of I have no knowledge about it. But some of my general experience would be like when I've done work in East Africa, is that the communities there are literate communities actually, but like are very aware. And there are reasons why some of these countries are ahead, like in banning single-use plastic bags. It was done years ago in India, years ago in Kenya. And part of it is because maybe the waste treatment plants, like we don't see our rubbish. And in some countries, it's much more visible, and so you react to it. But I think that's also true for countries that experience harder heat waves and harder extremes already. You don't necessarily have to be reading the IPCC report if you live in a place that's hit by extreme monsoons or massive heat waves every year to know. You would talk to your grandparents and they would say it wasn't like this when I was a kid. So both fortunately and unfortunately, I think the changes are now becoming so visceral, like that I think people are aware. I mean, I also think that it's good to keep educating and keep explaining and making sure that the correct information is out there, because the world is full of misinformation, even for people who are literate. So I don't know, like I'm a big fan of an advocate of any kind of education programs which empowers people with knowledge from which to platform their next step. What should we do next? How should we plan? I used to work in a research institute in Chile where like there was a whole ecological section. I was kind of in charge of water because of my connection to ice and the cryosphere. But our colleagues in the ecology department were more or less only working at trying to change public perceptions to reintroduce drought-resistant crops, because for the northern part of Chile, the forecasts are it's going to get drier, and drought is already a problem, and water availability is already a problem. So that needs planning from the water side, and it also needs planning for like accepting. And the weird thing is that the crops they're trying to reintroduce, I actually don't really know how to say quinoa, but it's traditionally grown in the area and then became unfashionable and considered an unattractive foodstuff. And actually it would be quite a resilient foodstuff in the future climate. So I think there's, maybe that's almost a little bit irrelevant, but we participated, for example, in lots of outreach and combined education seminars to the public. Seminars, you know, it's just a talk. It's a cup of tea and a chat in a room where you kind of explain what I know is projected for the climate, and my ecology colleague says, so for these things, when you're finding it hard to grow these, there's this and this. And you can't tell people to change. You can only provide them information to try and make choices. And the thing is, they won't believe you if they don't trust you. And this is also why it's really important for us to learn to talk and communicate and connect in a useful way, a way that makes sense to the people that you're trying to connect with. Like, I don't want to tell somebody to do something just because I want to be the boss. I want them to know, maybe, you know, maybe the Chilean farmers have a better solution than our suggestions. That's cool. That's great, actually. They can tell us what we should do instead. But if they're not aware that there's a problem coming and what the shape of that problem would be, and we can look at it together with like, okay, how have the last 10 years been going for you? What do we need to do to change this? It's the same in my research group here we did quite a big research project with farmers in the Peruvian Andes, and they were reporting that there was a drop in rainfall, and it was very dry, it was very dry. And it turned out through like lots of conversation that what was missing is like the annual averages and monthly averages of rain. When we looked at all the data, it's the same. But the point is there's a very particular kind of rain that comes, and they call it the puspa rain. It's basically a drizzle, very light rain, and it dampens the soil, but it doesn't wash anything away. And it's the perfect rain for when you put seeds in the ground. And this particular rain has been failing. So it affects how that community farms. And if we don't talk to them, we just look at our data and say, but the monthly rainfall hasn't changed at all. These guys are idiots. I mean, hopefully we wouldn't say these guys are idiots, but you can see the source of like miscommunication if you're not really exchanging, because that kind of rain is changing and has changed. And it means that when they put the seeds in the ground, it's either too dry or it rains heavily and the seeds are washed out. Rubbish. They need this if they're going to continue the farming practices they've been using. Interesting stuff, complicated. Yeah.
And India is a really interesting country because, as you told, energy is one of the most impact on CO2 emissions. And India was one of the first countries where PV electricity was cheaper than carbon energy. So to change from carbon to renewables in India is really close ahead. And it's a political decision to make. Yeah, the prices are good. And the solar sunshine radiation is very good in India. They have big gains in this. So yeah, that's really true that people should be informed about and learn about. So thank you very, very much for your presentation. Thank you for coming, and yeah, see you next week. And
Thanks from my side too. It's great to meet you.
Thank you.